Hello friends, so today we will create a swap, means we will swap the faces using the OpenCV. So let's get started. Let me show you this as an example. Has to this image 1 with image 2 and image 2 with image 1. As you can see, it's perfectly aligned. So let's get started. How we can swap the face using the OpenCV. So these are the libraries which we required: CB2, MediaPipe, NumPy, and Matplotlib for the plotation purpose. Okay, the images which we are using is this one, and Iron Man, and the second one is you can say Elon Musk. Okay, let's get started. So first of all, we will read the image. This is the we load the images, image one and image two. Then we will check that particular that image one is there or image two is not there. We have to means print the error. If suppose image one is not there or image two is not there, then we will exit to the cell. After that, we will get the landmarks. We want to get the landmarks means we have to get this landmark of the face. Okay, like this is, for example, I have make it this. I want the landmark of this face. How I get it? For that, I already created this function get landmark. It give me the landmark for the image 1 and image 2. So go to the landmark function. As you can see, this is the function for the get landmark. Before that, in this we are just passing the image to get the landmark of the face. First of all, this is the get height and width of the image. Then we already know that the image which we read by the CB2 is in a BGR format, so we have to convert that into the RGB. For that purpose, we use cb2.cbt color, then image, then cb2 dot color BGR to RGB. It convert the image from BGR to RGB. Then we want to get the result, or you can say the face landmark. For that purpose, we use face mesh dot process dot RGB. So what is this face mask? Though for that purpose, we have to initialize the face mask. In that, we use this MediaPipe mp.solution that face mask mid load module. After that, we want to this initialize face mask model. So how we can define it? This is the other attributes which we use. Okay, so for that purpose, we use mp face mesh dot face mesh. First of all, the attribute will be static image mode. True means used for static image, not video. Max number of face which want to detect only one face. And refine landmark, improve landmark accuracy. Okay, true. This way we get a face mask. After that, we will just load them. Means the model is ready. This face mask model is ready. We just have to give the you can say image to detect the face or to get the landmark. After that, if suppose no face is there in the image which we have given to the get landmark function, we return none. Otherwise, we have to store all the, you can say, what we want to store. As you can see that each pixel means each point has a x and y coordinates value. Okay, so and we want to also normalize scale them. So for that purpose, to get the x y coordinate value, and also we want to unnormalize them. Of course, for that purpose, we use first of all this thing. Let me explain you. We loop over this result multi-phase landmark 0. Why 0 index value? Because we want to detect only one phase. We would only want landmarks value, landmark details of the only one phase which is detected by the model. That purpose 0 index value is required. And what we want a landmark. So that purpose, for that purpose only, we loop over it. After getting the, you can say, after getting this lm will, basically for each point it's contain x value and y value, pixel value, and all pixel value is in an unnormalized way. Let me print this for your sake. Print, what do you want to print? Lm. I want to print the lm, and I just want to break that here. Okay, now let me run it. Okay, but it, I think so it will throw me error. Okay, so let me show it's printed or not. See, you can see that the values, this coordinates values, x and y and z, it's three having three value, but x y value you already know this is in a you can say it in normalized format. What we have to unnormalize them according to the width and height of the image. For that purpose only, we have to multiply with lmx with width and dot y with height, and after that we have to convert them into integer. So this is the line, two line is doing that purpose. After getting the x and y pixel value, we will append into the list which is empty, which we have created it. Okay, then no break is required now. Okay, after getting the all x and y coordinates value, or you can say face landmark each point x and y coordinates value in unnormalized format according to the weight and height of the image. We just want to convert that list into the NP array and return that landmark details. Okay, so let's get started. Come back to the function which we want. I think so. Yes, now it's okay. So after getting the landmarks of image 1 and image 2, we want to check that particular landmarks list which we cat MP array is, you can say it's empty or not. Otherwise, we have to exit it. After that, we have to swap the face. The main function is this one, swap the face. In this, we are passing the image 1 which act as a source. Image 2 will act as a destination, and also we have to pass the landmark 1, means image 1 landmarks for the face, and image 2 landmark for the face. After that, we will move to the uh, swap face function where we swap the face between the source and destination. Let me explain to you about what is source and destination, how it's working. Suppose image 1 will be the source and image 2 will be the definition destination. So swapping the face between the image 1 and image 2, it means we have to extract this face from the image 1 and paste that face into the image 2. So this is the swapping of image 1 with image 2. Okay, so this is the meaning of the source and destination in this. After moving to the swap face function, we will be just passing the image 1 and image 2, means a source image, a destination image, source landmark, and a destination landmark. Let me talk you. So first of all, we want to extract the bounding coordinates values x, y, and y1. For that purpose, we use bounding rectangle source land. Just pass a source landmark. We will get the bounding box coordinates value of the face. Okay, and x1, y1, and w1, w1, h1, and same before the second image, which is a destination. After that, we will extract the, we can say, crop source face. Now we will extract the source face from the image. Okay, for that purpose we use y1 plus h1. So this way we will extract the, you can say, y1 and y2 will act as a number of rows, x1 and x2 will act as a number of columns which we want to extract from the you can say image. Means from y1 till y1 plus h1 we have to extract the rows. X1 till from x1 till x1 plus w1 will act as a number of columns which we want to extract. Okay, so for example, suppose this will be the source and this will be the destination. So when I will extract the face from this, we will get this type of result. Okay, after that, after getting the source face, I want to resize it. I want to resize it according to the destination face. Okay, W2 and H2. I want to resize it the face of my matching destination. So the result which I will get is like this. Okay, I will get this like this. You can see here the destination will be. You can see this size will be 140 plus, but here the after resizing it according to the destination face WH in height, width and height, its size decrease 120 plus. Okay, so this way we get it. We have to resize it to perfectly fit on the destination image face. That's why we have to resize it. After that, we want the mask also. So for that purpose, when we use create mask and we are passing the source image and a source landmark, because the mask which you want is related to the source image only. So that's why we are passing the source image and a source landmark only. So here we come to the source, creating the mask function. Open it. Why it's not opening? Oh, open it. See, after getting the image and landmarks, we will first create the mask according to the height of the image, which according to the source image, we will create the mask of all pixel value will be 0 of data type unit 18. So it's look like this one. As you can see, it's look like the source face masks. Okay, then what is this CB2 convex or landmark? What this means is that let me show you one thing. See here, when convex solve, when we use that particular thing, this suppose your original image, the result after that when we use the convex solve, it give me this type, means the boundary points. Like for better explanation, suppose this is a landmark, this is a landmark, perfect landmark, but I want this boundary coordinates value, so that inside this region I can change the pixel value from black to white. Okay, for that purpose only. uh, for that purpose you use convex all, which give me the boundary coordinates value of the face landmark. After that will be use fill convex poly and mask and the coordinates value, and every inside means inside this boundary region every pixel value will changes to 255. So how and after that it will return the mask. So how it's look like, let me show you. See, after a year, it's look like this thing, this way. Means this particular reason pixel value will be 255. Okay, then after getting the mask, I want to resize it. This crop mask to the face. Again, we will crop this face from the source mask. So it's look like this, and again you get the destination will be, because the size of it will be 140 plus. When again we have to resize it according to the destination height and width of the face. So that only after getting the crop, after extracting the crop, I want to resize it according to the destination width and height. So this way I get a source mask. Okay, so first thing I get a source face and a source mask. Now this is a center means that means the what does it mean? Compute center point. What is the meaning of compute center point? Is a placement center. Means from that center only we will replace it. Okay, so how we calculate it, and it's basically calculating using a destination. You can say destination bounding box around the face. Okay, for that purpose, how we get a center of the particular thing, we will use x plus w2 divided by 2 and y2 plus s2 divided by 2. This way I get a center for the center of the destination image face bounding box. Okay, then it's very simple. We use this seamless clone here, which is past the source image. Means after this I will get a perfect image with the swapping face. Here we pass the source image, destination image, source mask, and the center, and the, you can say, normal blending mode. Here we wanted the normal blending mode. Then after that I get a complete output with the swapping face. Okay, so this way swap face is working. And same way for the image to swap 2 to image 1. When I want to say swap face to a swap 1, then I already know, I already told you that the images which we get is already in a VGA format, so we have to convert that into RGB. So image 1 we have to convert, image 2 we have to convert, swap the image to swap to 1, we have to convert the swap to image which we have get. Okay, we have to convert that into convert them to RGB. Now I want to plot the images. So what were all images I want to plot? Original image, original image 2, the image when the image 1 is swapped with image 2. Okay, when image 2 will be image 2 means this one is swapped with image 1. Okay, so how it's working, let me show the plotation. For that purpose we use plot the figure size will be 12 by 8 tan figure size. Now this is how many plotation? Four rows, means 4 images is present, and 2 means 2 rows and 2 columns. So 2 rows, 2 columns, and first image will be image 1 RGB, means original image title, then the axis will be off. Now second image, for second image 2 rows 2 column, and inside that second image will be second image means image 2, then original image 2, and in third 2 rows 2 column, and the third image will be image means swapping of 1 to b and with RGB. So this way the plotation is going on. After that we have used plot.typeplot and plot.show. So this way the swapping of the images is performed. Okay, so let me run this so that we can see the result. See, when the image image 1 is source and image 2 will be destination, I want to paste this face, I want to paste the face from here to here. So this result I get. And when the image 2 will be the source and image 1 will be the destination, and I want to paste this face to here, I will use this is the result of that. See how perfectly they are blending and getting the result, perfect result. So this is the way we swap their face using the OpenCV. Hope you gain something from my video. If you gain something from my video, please like and share my channel. Thanks to all.